Okay, so deep red has the same property that you can remove it, that red can remove it and replace it by a finite number of reds. Right? So based on what we just learned about with deep blue, what do you guess the value of deep red is?
Maybe it's negative. Yeah, negative infinity.
It probably is going to be negative infinity.
Because you can have any finite number of blues, and then just remove this and replace it with any finite number of reds, or the same finite number of reds.
Interesting. So studying carefully the deep red isn't necessarily going to be all that interesting.
Because it's basically the opposite of a deep blue.
Yeah, so instead what we're going to study is this interesting situation. Blue with a deep red on top of it versus a red.
Well, if blue goes first,
Then blue can, well,
blue would remove this. Blue
Okay.
has to.
All
that
right.
would remove the deep blue.
All right.
The deep red.
All right.
And then red removes the...
And blue loses.
Okay. All right. So whatever the value of this is, red wins,
Yeah.
right?
Well, what if red goes first?
Yeah. Good. Let's double check.
If red
It
goes-
seems like the value of blue deep red plus a red is negative, right?
Yeah.
Okay.
Well, if red goes first, red can remove the deep blue and put a red on his... A red.
Well, if red removes this red, blue removes both of these and red loses.
Okay.
So red wants to remove the deep blue.
If red removes the deep blue, the deep red, would it still be stacked? Would this still be stacked on it?
Yeah, you would replace the deep red by, say, whatever stack you wanted, however many reds you wanted.
Well, it really doesn't matter how many reds you take, because blue is just going to remove the blue.
Okay.
So, and then red removes that, blue can't remove anything else, so blue loses.
It's interesting. And I forgot one part. I started at step 2 here. What if it's just a blue with a deep red on top? Who's going to win this game?
Well, it would be blue, because when red goes first, red removes this and replaces it with any number that they want.
Then blue removes...
Blue removes all. Red can't remove anything.
Okay. So that means the value of this must be what?
It must be positive.
Must be positive. Okay, but this plus minus 1,
is negative.
red one, this one.
So that means this has to have a value of... It would have to have a value of less than 1.
Less than 1. Okay. What about blue, deep red versus red red?
Well,
What
in this
happens
situation,
here?
it looks like it's going to be a negative situation.
Oh, actually, sorry. I'm goofing up. My mistake. It's not versus red red. It's blue, deep red, blue, deep red. So 2 of these versus a single red. That's what we want to study. What happens now?
Well,
Because remember, this is positive, but one of them wasn't enough to overcome a 1. Maybe 2 of them will be enough to overcome a 1.
well,
What happens here?
so if blue goes first, blue removes that. Then red,
Can remove the deep red.
well actually, yeah, red would want to remove the deep red because it's the same scenario that we studied before. If red removes this, red loses.
Okay.
So red removes it, replaces it with any number. Blue takes it away,
Yeah.
And red takes...
and red takes this away, and then
Blue loses.
Blue loses, yeah.
Blue loses. Okay. So it seems like 2 of these are not able to overcome a minus 1.
But
So what does that mean?
That means
three.
it's less than a third. It's less than half.
It's less than a half. Let's try 3 of them. It's positive.
Yeah.
We know it's positive, but it's less than a half now. What if there's 3 of them?
Well, so if blue goes first, blue removes this, red removes and replaces, blue removes that, red does the same thing, red wins.
Means it's less than a third.
But you can just keep doing this. Like if you have a million of these, it's all going to boil down to this situation.
Yep.
Where red wins.
Okay.
So that means this is infinitely close to 0, but not 0 itself. It's still positive, it's just a tiny bit above 0.
Why did you just hit your head?
It's I think maybe it's cracking.
You think your head's starting to crack? So this is interesting. So the value of a blue deep red is positive.
But not, it's infinitely close to 0, but not 0.
Yeah. Weird, huh?
Yeah.
But there it is right there. There's a number. Sort of a number. That's infinitely close to 0, but not 0.
But then, if we remove this, it becomes negative infinity.
Whoa, what? Strange, huh?
Yeah.
Yeah.
All right, now let's move on to the deep purple, okay?
Okay.
Alright.